Hey everybody. So today we're going to get into some more of the MCAS problems from the spring 2019 test release. So if you have not watched some of these previous videos, in the video description there's a link to the digital platform in which you should try these problems first. And then you should watch these videos. So try it first, click on the link, and give it a shot, and then you can watch it. That's what I'd recommend. There's also a PDF you can print up, which is this one. If you're one of my students, you should already have this copy. Okay, let's get right to it. So this first, number 15. A rectangular garden that is 16¼ feet wide and 11¾ feet long will be covered with soil. If a bag of soil covers an area of 20 square feet, which of the following is the closest to, it's important, to the number of bags of soil needed to cover the garden. Okay, so as soon as you see the word closest, or the phrase closest to, we know we're dealing with an estimation problem. Okay, we're going to be estimating here. So we know we're dealing with a rectangle. Okay, and again, you want to be using your scrap paper for this. Really, all of these problems, you want to be using your scrap paper. Okay, so 16¼ by 11¾ So I'm going to round it down to 16. I'm going to round this up to 12. Okay, this is a quarter short. This is a quarter. Well, it's quarter large. Is a quarter short, so it should be even out. So 16 by 12. Let's find out what the area actually is. 16 times 12. Let's see. That should be 32. 16, so 192. Okay. All right, so this is roughly 192. Roughly, again, we estimated here, right? 122 square feet. Now, a bag of soil covers 20 square feet. So how many bags of soil would it take to fill this? So let's divide 192 by 20. So 192 divided by 20. Let's see, I think it's going to be 9, 180, and this will be a remainder of 12. This would be 9 and 12 over 20. And unless you have a calculator combination, you wouldn't have a calculator for this problem. So 9 and 12 over 20. So this is a little over 9½, right? Because a half would be 10 over 20. So a little over 9½ would mean it's closer to 10 than it is to 8, right? So that's why we put 10. Now you could simplify this. 12 over 20 is actually 6 over 10, and 6 over 10 would be 9 and 6/10, which is closer to 10, right? And 10 is the answer for that one, okay? So this requires you know how to do a few things. 1, you want to be able to estimate, and 2, you need to be able to calculate the area of a rectangle, and 3, you need to understand that the bags of soil, that value you divide into the area of that rectangle. So there's a few things going on here. It requires a little bit of forethought, or foresight rather. That's even a word. All right, number 16. Here we go. So there's a two-parter. All right. First one's asking us. Let me zoom in a little more here. This one's asking us to identify two similar triangles. So similar triangles have 3 congruent angles, and you'll notice they gave us 2 angles for all of these. So all we need to do is find the missing angle for each of these. We can add these 2 angles together, subtract from 180, and that should give us the remaining angles. So let's do this first one, 68 plus 74. Okay, that's going to give us 142. Let's subtract that from 180. And that should be what, 38? Yep. So this is 38 degrees. I'll zoom in a little more. Okay. Let's do this one. So 45 plus 68. That's 13, carry the 1. Was that 113? And then subtract 113 from 180. And that'll be, what, 67? Yep. So this is 67 degrees. Okay. Let's try this one. So 45 plus 74, that's going to be 119. Subtract that from 180. And that's going to be, what, 61? Yep, so this is 61 degrees. And then this last one, 38 and 68. And that's going to be carry the 1, 106. Then 180 minus 106 be 74. Okay, so it's going to be these two triangles because they have 3 pairs of congruent angles, 38, 68, 74. Let's do this one and this one. Okay, that's part A. Let's look at part B. these two triangles are similar. Okay. Drag and drop. Ooh, a little zoomed in too far. Sorry. Drag and drop the vertex labels into the box to correctly complete the similarity statement. Okay. So this is 74 degrees. Actually, I'll do. You know what we're gonna do? We know what this third angle is, but we don't need to know what this third angle is. Actually, we'll just label that as a single arc. Single arc. Yeah. 74 will be the double arc. And then 68 will be the triple arc. All right, so E is the first letter. E is our single arc. So Z would be our first letter. F is our second letter. That's our triple arc. So our triple arc is down here. That's X. And G is our double arc. Y is our double arc. And that's how you do it. It's really just a lot easier if you label the sides. So again, you'll have scrap paper, but also every student will have a dry erase marker, so you could literally just draw these arcs on your screen. That'll work for this one. You don't really need scrap paper for this part. If you don't want to use the marker, you could draw these, and that'd be fine. Okay. But again, for this previous part, though, for part A, you definitely want to be using scrap paper to write that out. Okay. All right. So that was number 16. Number 17. Okay. So which of the following is equivalent to this expression? So there's two ways to solve this. You can factor this, or you can distribute it. It is much easier to distribute these and solve it that way, in my opinion. You can factor this if you're really comfortable doing it, but most of you probably either forgot how to factor because it was at the end of last year during COVID, or you didn't really get enough practice with it, and I think you feel much more comfortable just distributing this. So let's go ahead and do that. Okay, so we're going to distribute this x. X times x is x squared. X times negative 14 is negative 14x. Now I'll distribute the 6. 6 times x is positive 6x. And 6 times negative 14 is negative 84. Now we have to combine these like terms right here. I'll zoom in a little more, it's kind of hard to see. That's a little better, okay. So x squared, see negative 14x plus 6x would be negative 8x minus 84. So that's not it. Okay, let's try B. So I'll distribute the x. And it's going to be x times x is x squared. X times 14 is 14x. Now be careful, this is a negative 6, so don't forget that negative sign is being multiplied along with that 6. So negative 6 times x is negative 6x. And negative 6 times 14 is going to be negative 84. Combine these like terms here. And that's going to be positive 8x. Yeah, so x squared plus 8x minus 84. Again, this is not it. They both have negative 84, but they don't have that positive 5 in the middle, so that's out. Let's try C. So distribute the x. X times x is x squared. X times negative 12 is negative 12x. Don't forget that negative sign. Distribute this to positive 7. 7 times x is positive 7x. And 7 times negative 12 is negative 84. Okay, let's combine these like terms in the middle. X squared, it's going to be negative 5x. Yeah. So we almost had it. So it better be D, right? And then the last one, this should be it. X times x is x squared. Oh, let's scroll down here a little bit so you can see better. There we go. X times 12 is positive 12x. Negative 7, keep in mind that's negative 7 times x is negative 7x. And negative 7 times 12 is negative 84. Let's combine these like terms. 12x take away 7x will be 5x. So yeah, we got this now. Here we go. It's positive. We took the sign of a large number. There we go. So it takes a little while, but just distributing it makes this problem, I think, fairly simple for you guys. Okay? You can try to factor, but I wouldn't recommend it. I'd recommend just distributing this. You could draw with a marker on the screen, but I think you'd have a better time, honestly, writing this down and solving each one. Just be careful if you write this down on your scrap paper that you write down these options correctly. Don't do it too quickly. You can make a simple mistake just by transcribing it. Okay, number 18. Okay. So this one's a little tricky to show on paper. So make sure you've tried this one on the digital platform before you watch this part of the video, okay? All right, triangle KLM, which is right here, is shown in the coordinate plane. It will be dilated by a scale factor of 1/2 with respect to the origin. Graph the image triangle KLM, this should be primes here, but you can't really see that, after the dilation on the coordinate plane. Oh, the image of triangle, okay, never mind, this is actually correct. To graph the triangle, select the place in the coordinate plane to plot the vertices. Okay, so we essentially need to dilate this. So the first thing we want to do is write down the coordinates of this, and you would want to write down these coordinates on your scrap paper. So first one's M. So M is 2, 6. L is going to be 6, -4. And then K is going to be -6, -2. Okay. So to apply the dilation, it's 1/2. We're just going to multiply 1/2 by these coordinates. That's all we're going to do. Okay. So M prime, what's half of 2? 1. What's half of 6? 3. That's simple. Half of 6, 3. Half of -4, -2. Then K prime, half of -6 is -3. Half of -2 is -1. Okay? So those are the coordinates of our image now. It's going to be dilated. So 1, 3 is 1, 3, and that's our M prime. 3, -2. That's our L prime. -3, 1. Sorry, -3, -1. That's our K prime. So when you plot those points on your computer, it'll automatically connect them. And you don't have to worry about labeling them or anything like that. But this part here, figuring out the coordinates, it's just a simple matter of multiplying this dilation factor, scale factor of the dilation by the existing coordinates. Okay? So writing this down is going to be really, really important. Okay. Number 19. This one throws people off if they don't use a few tricks we're going to learn about right here. So I imagine this will definitely be on the test or something equivalent to this, because there was an example just like this on the practice test of this particular problem. Two-parter. First part, determine whether the statements in the table about rational and irrational numbers are true. Select true or false for each statement. So let's read each one. The sum of two rational numbers is rational. The product of two rational numbers is rational. The sum of a rational number and a irrational number is rational. So I find this to be a lot easier if you plug numbers in for what they're telling you. So rational number, I'm going to pick the number 2 and 3. So sum is addition, right? So sum of two rational numbers. So okay, let's do 2 plus 3. That's 5. Is that a rational number? Yes. Remember, a rational number is a number that can be expressed as a fraction. So integers can also be written as fractions. This could be 2 over 1, 3 over 1, 5 over 1. So these are going to be my rational numbers. Sum, okay, 2 plus 3 is 5. Yeah, that's true. The product, remember that's multiplication, of two rational numbers is irrational. In other words, irrational would be a number that cannot be written as a fraction, like pi. Pi is a great example. So let's multiply 2 times 3. What do we get? 6. Is that irrational? No, that is rational. False. The sum of a rational number and an irrational number is rational. Okay, so sum is addition. So we'll do 2 for rational. Plus, irrational do pi. Is it rational? No, it's not rational because this is as good as it gets. We can't really simplify this anymore. And as long as there is an irrational number here, that means the whole thing, this expression is irrational. So no, it's not rational, it's false. Okay. I think using the examples honestly makes it easier if you plug values in for that and make sure you identify what operation we're talking about. So 1, you need to know what sum means. You need to know what sum is addition. And 2, you need to know what product means, which is multiplication. You could also have quotient and difference, right? Quotient is division and difference is subtraction. All right, let's try part B. Here they actually give us the examples. Drag and drop a phrase into the box to correctly complete each statement. Each phrase may be used once or more than once or not at all. Okay, so you don't need to use both of these. That's the important part. A lot of students, when they took this, they thought you had to use one each, which is not the case because you're actually going to use the same one twice. All right, so the sum of pi over 2 and pi over 2 is blank. So let's add that actually. Pi over 2, sum is addition, right? So pi over 2 plus pi over 2, well, that'd be 2 pi over 2, which is pi. It's irrational. Okay? Now, it would be possible if this was negative pi over 2 and this is positive pi over 2 to equal 0, which would be rational. So, yeah, sometimes it could be rational, but not in that case. The product of 1/2 and pi is blank, so product is multiplication. So 1/2 times pi is pi over 2, and that is irrational. Okay. Irrational. Okay. I'm going to do a few more. I think we have time. Yeah, we have time. So number 20. Which of the following is a solution set of this inequality? So we just have to solve this inequality here. So we're going to, again, you would want to write this one down on a piece of paper or use the dry erase marker. I would probably write this one down. So negative 4y is greater than 12. And here we have to divide both sides by our coefficient. Zoom in a little more, which is negative 4. Now here it's requiring you to remember the trick here, or there's a rule. When you multiply or divide both sides of an inequality by a negative number, this inequality symbol changes direction. So this becomes y is less than negative 3, which is b. So it's very easy to forget that. If you multiply or divide both sides of an inequality by a negative value, the inequality symbol has to change direction. So don't forget that. That's really important. Okay, 21. We have time for like 2 more probably. Yeah, we do. Okay, so 21. A right triangle and some of its measurements are shown in this diagram. All right, so some people get confused by this because it's a right triangle, but we're only given one side. So they might be asking themselves, well, how can you find a missing side if you only have one of them that's a right triangle? Well, because it's a special right triangle. Okay, this is a 90, this is a 60. That means this is a 30. Okay, so if it's a 30, 60, 90, that means it's a special right triangle. And the formula for that is found in the exhibit button, so which gives you the reference guide. So if you're looking at the digital version of the test, which you should be, you press the exhibit block, which is on the right-hand side. It'll bring up the reference sheet, and this is there under special right triangles. Okay, so just make sure you draw in the 30, and I think that'll make it more obvious to us. All right, so if you do that, you'll find that it's going to be, they say y, so I guess we'll use y. I just hate it when they use a specific variable. So 2y is the hypotenuse. The side opposite the 30 is just a single variable, and then this is going to be the variable times radical 3. Okay, so we're looking for t here. We're looking for that one. All right, so if we have 2y, which is what we have, we can find y just by taking half of 12. Half of 12 is 6. So this is 6. And we're looking for this side, and it's this side times radical 3. So this is just 6 radical 3, which is option C. Okay, so again, this requires us to be comfortable with our special right triangles. But students would look at this and sometimes not even recognize that it's a special right triangle because they don't give us the 30. You have to know that. Say, oh, 60, 90, oh, this is 30, right? And then, boom. So this one may be easier with a marker because you can draw right on the screen for that one. I don't know. I'd use both if you need to. All right, we'll have time for one more. We'll do this one more. Number 22. Okay, here we go. So this diagram shows a right square pyramid and some of its dimensions. What is the volume of this pyramid? Okay, so the first thing I want to do is look for the volume formula, which is again on the reference sheet that we just used for number 21. And the volume of a pyramid formula is as follows: 1/3 capital B H. Now this capital B confuses some people. That is the area of the base. Okay? So the area of the base of this shape is what that capital B is. So you need to calculate what that area is down here. That's squares. It's a square pyramid, right? That means the base of the pyramid is a square. And then multiply it by the h. Now the h is not the slant height. It's actually the perpendicular height, okay? It's perpendicular symbol, upside down T. So this is actually the height we're talking about here, not this one. That word, just having slant height, the word height, students see it and they say, oh, 5. No. We're not, this number we're actually not using at all. All right, so first things first, let's figure out the area of the base. So this is 6, it's a square, that means this is 6. The area of a square is the length of the two sides times themselves. So 6 squared is 36. So I guess I put a big B. I guess I should do that. So 36. So it's 1/3 times 36. Now what's the perpendicular height? It's 4. Okay. So 1/3 times 36 is 12, and 12 times 4 is 48. So it's 48 cubic inches because volume is in units cubed. So it's letter A. Okay. So yeah, that one you got to be careful because some students may not remember what the capital B is. So just be careful of that, and also be careful of height. They're trying to trick you here with the slant height. That's not the height they're looking for. They're looking for the perpendicular height. This is literally just here to trick you. Have you throw it in? Because if you do that, you're going to get 5 times 12, which is 60, which is option B. So B is the option they're trying to trick you into choosing there. Okay. So be wary of that. All right, so that's a pretty long video. Sorry, it went a little longer than I intended, but so we're about halfway through with this spring 2019 test. I'll try to get another one later today, definitely one tomorrow, and the goal is to finish these by the end of the week. All right, and that gives us a week before the test to even go through more if we need to. All right, thanks for watching, guys. Let me know if you have any questions.